Professor Albert Einstein, who helped discover the atom bomb.
What do you put the chances of having found life?
So we have the observations, they're beaming in right now. So we're waiting for the data to come to us, and the analysis will start anytime.
Scientists have reached a significant milestone in the search for an interstellar home. In a surprising discovery made by the James Webb Space Telescope, they found a new planet with properties strikingly similar to Earth. Experts are now speculating that this planet could be the ideal home away from home and may already host extraterrestrial life. However, in the midst of this excitement, researchers in the scientific community stumbled upon yet another planet that could be even more suitable for humans than Earth. What are these newly discovered planets, and where were they found? What attributes lead experts to believe these planets are suitable for human life? What are the chances of finding intelligent extraterrestrial life on them? Stay tuned, as NASA has just uncovered a new planet better for life than Earth. With the growing threats of global warming, climate change, pandemics, and natural disasters, scientists believe Earth is slowly approaching a point of no return. It's only a matter of time before a catastrophic event could wipe out humanity. In light of this, researchers have been searching for a new planet in the cosmos that could serve as our next home, much like Earth. Initially, the search focused on planets within our solar system that could potentially support human life. This led the scientific community to send probes to various planets throughout the mid and late 1900s. Because Jupiter and Venus were too close to the Sun, the best options were narrowed down to Mars, Jupiter, Saturn, and Uranus. However, it became clear later that none of these planets would be suitable for human life. Jupiter's weather is extremely unstable, making it the most unpredictable planet in our solar system. Saturn's atmosphere is rich in hydrogen and experiences helium rain, while Uranus lacks oxygen, making it impossible for humans to breathe there. The most promising candidate so far is Mars. Although Mars is dry, arid, and prone to dust storms and radiation, experts like Elon Musk remain optimistic about making it habitable. Plans to establish a base on Mars are already in progress, but creating such a base would be challenging. It would require replicating Earth's conditions, including oxygen, gravity, water, temperature, and air pressure. The cost of such an endeavor would be astronomical, amounting to billions or trillions of dollars. It would be far easier to find a planet with the right conditions elsewhere in the universe rather than transforming Mars into a habitable one. As a result, scientists have expanded their search beyond our solar system, exploring distant regions of space to identify a planet like Earth, or perhaps an even better one. To streamline the search for a suitable replacement, scientists developed the Earth Similarity Index. This index evaluates planets using factors like temperature and atmospheric pressure to determine how closely they resemble Earth and whether they could support life. The scale runs from 0.0 to 1, with higher numbers indicating a closer match to Earth. For instance, a planet with a similarity index of 0.9 would be nearly identical to our planet. With significant technological advancements, scientists have been able to explore the deepest regions of the cosmos, revealing promising candidates for human habitable planets. Among these are exoplanets and moons with striking similarities to Earth. One notable discovery from 2019 is the planet Teegarden B, one of the closest potentially habitable planets, situated about 12.4 light-years away. Its mass is 1.05 times that of Earth, making it almost identical in size. Teegarden B orbits an M-type star, Teegarden, a red dwarf. These stars are relatively cool, with surface temperatures below 3,600 Kelvin. The Teegarden star in particular is much smaller than our Sun, with a temperature around 2,700 Kelvin. Despite its low heat, the red dwarf provides enough warmth for its planets, Teegarden B and Teegarden C. Teegarden B orbits its star at a distance of 0.252 astronomical units, while Teegarden C, the other planet in the system, orbits at 0.04 astronomical units, completing its orbit in about 11 days. Both planets share characteristics with Earth, notably being located in the habitable zone of their star. This zone refers to the distance at which liquid water could exist on the planet's surface. If too far, the water freezes, too close, and it evaporates. For example, Neptune has frozen water due to its distance from the Sun, while Venus lacks water altogether, even in its atmosphere. Earth, however, is at the perfect distance for life. The discovery of Teegarden B and C indicates Earth isn't unique in this regard. Teegarden B stands out with a promising score of 0.95 on the Earth Similarity Index, ESI, which means it's nearly 100% similar to Earth. However, uncertainties remain regarding air pressure and temperature, with estimates ranging from 0 to 50 G. If its atmosphere is Earth-like, its surface temperature could be around 28 G. Teegarden C, being farther from the star, is more likely to be too cold. Experts believe it has only a 3% chance of a warm surface temperature and suspect its atmosphere may resemble Mars, with temperatures near 47 degrees Celsius. Its ESI score is 0.68. Currently, researchers don't know much about the atmospheres of Teegarden B and C, as both are tidally locked to their star. Scientists estimate their atmospheres could be 13 to 17 times denser than Earth's. There's plenty of speculation about these two planets, with some believing they could be future homes for humanity if Earth faces a catastrophic event. On the other hand, many scientists are also exploring the possibility of extraterrestrial life on these planets. For centuries, we've questioned whether we are alone in the universe. This mystery has driven both astronomy and cosmology. Despite extensive research, no alien civilizations have been found. No stars or planets have yet exhibited the ideal conditions to support extraterrestrial life. The planets that are thought to be viable for life are those with the right temperatures, atmospheres, and those situated in the habitable zones of their stars where water can exist. Water is essential for any living organism. As the saying goes, water is life. Scientists have long recognized that wherever water is present in the universe, life can likely be found. This is why planets such as Teegarden B attract significant attention when researchers search for planets that might harbor alien life. But Teegarden B isn't the only planet of interest. Other planets are also considered strong candidates for supporting extraterrestrial life. One planetary system in particular is seen as even more promising than Teegarden, the TOI 700 system. Located in the constellation Dorado, this star system contains 4 planets, with 2 of them residing in the star's habitable zone. The standout planets are TOI 700D and TOI 700E. Both planets have masses comparable to Earth's and feature rocky surfaces. TOI 700E is approximately 95% of Earth's size, with an orbital period of 28 days, while TOI 700D is about 105% the size of Earth, completing its orbit in 37 days. What makes the TOI 700 system particularly intriguing is its age, around 1.5 billion years. That puts it just a few billion years younger than our solar system, which is about 4.6 billion years old. According to cosmic timelines, 1.5 billion years is more than enough time for life to develop and evolve on a planet. Some experts believe that TOI 700E and 700D could host rich biospheres. If these planets have atmospheres warmer than Earth's, they could not only be suitable for us but also for alien species with similar biological traits. If we were to find life on these planets, it would likely resemble the life forms found on Earth, as we tend to look for biological traits that are familiar to us. However, this is all speculative at this stage. Until we can closely study these planets' atmospheres, surfaces, and environmental conditions, we may never truly know what kinds of life forms they might host, if any at all. It's possible that planets scattered across the cosmos could house similar life forms, shaped by the same fundamental principles of biology. But there is still so much about the vast universe that remains beyond our comprehension. The potential for completely different evolutionary paths driven by conditions that are unlike anything we've encountered adds an even greater layer of mystery. For instance, the principles of evolution could function very differently on other planets compared to Earth. Evolution, like gravity, is thought to be a universal process. The concept of evolutionary convergence suggests that unrelated species can develop similar traits when they face comparable environmental challenges. Consider species like crocodiles, which have evolved to swim and breathe underwater. If similar creatures existed on water-dominated planets, they too would evolve to adapt to underwater environments. However, their evolutionary paths might differ. While some aquatic animals have developed gills to extract oxygen from water, others have not, relying on different adaptations for survival. Similarly, birds, insects, mammals, and other airborne creatures have evolved various methods to take to the skies, each suited to their specific needs. Birds, for example, soar by flapping their wings, generating the lift they need to remain airborne, while mammals like flying squirrels use a different approach, gliding gracefully by stretching out their loose skin to create a makeshift parachute. Every creature has its own unique way of conquering the air, whether it's through flapping, gliding, or hovering. It's highly likely that this incredible diversity of flight and movement is also unfolding on other planets with biolife scattered throughout the universe, where alien species have evolved their own specialized adaptations to navigate their environments. There is also a possibility that some of these planets could evolve complex biolife forms. These advanced life forms would be entirely different from anything we've encountered on Earth. Environmental conditions like temperature, atmospheric pressure, and water availability could heavily influence how these organisms evolve, driving them to adapt in ways that seem strange to us. Scientists are keeping their minds open to the idea of discovering biolife that defies our current understanding. On Earth, some organisms exhibit bizarre traits and have adapted to survive in extreme environments, from the deepest parts of the ocean to the hottest volcanic vents. These extraordinary life forms, known as extremophiles, can thrive in conditions that would be lethal to most other species, such as extreme temperatures, high radiation, or toxic chemicals. Their unique adaptations make them valuable models for the kinds of alien organisms that might exist on other distant planets with similarly harsh or unusual conditions. So far, most searches for extraterrestrial life have centered around planets with close similarities to Earth, focusing on finding life as we know it. However, studying extremophiles helps us imagine how life could evolve in radically different environments, expanding our understanding of where life might exist in the cosmos. But what if we change our perspective? Instead of limiting our search to life as we know it, we could widen the scope and explore the possibility of life that's fundamentally different. Life as we don't know it. After all, given how little we truly understand about the vast complexities of the universe, it's not unreasonable to consider that extreme biolife forms could be thriving on planets we've dismissed as uninhabitable. These planets may endure intense radiation, have an excess of particular elements, experience extreme temperatures far beyond what we consider survivable, or face severe, relentless weather. Yet in these harsh and hostile environments, there may exist life forms perfectly adapted to not just survive, but to flourish in conditions that would be unthinkable for organisms like those found on Earth. A few years ago, astronomers identified a new type of planets known as hen exoplanets, which may have the potential to support life. These planets are significantly larger, hotter, and covered with oceans, providing them with a wider habitable zone compared to Earth. Some of these exoplanets experience atmospheric pressures as high as 200 XU. They meet important criteria, including having substantial amounts of water. However, due to the extreme conditions, any biolife that might exist on these planets would be very different from the life forms we are familiar with. One fascinating example from this category is planet K2-18b. Discovered in 2015, it is one of the numerous planets found by NASA's Kepler Space Telescope. The Kepler Space Telescope, launched by NASA in 2009, was designed to search for Earth-sized planets orbiting stars within nearby regions of the cosmos. Named after the astronomer Johannes Kepler, the telescope was placed in a heliocentric orbit, meaning it orbits the Sun while gradually drifting farther away from Earth as it continues scanning the universe. Thanks to Kepler, scientists determined that approximately 25 to 50% of stars visible in the night sky likely have small rocky planets, much like Earth. Kepler's findings included multiple planets located within the habitable zones of their parent stars, and K2-18b is one such planet. Situated roughly 124 light-years from Earth in the constellation Leo, this planet is reminiscent of a mini Neptune orbiting a dim red dwarf star. Researchers suggest that planets like K2-18b could harbor life due to their potential to contain biomarker molecules. These molecules, often remnants of organic processes, can be detected in soil and water samples by space rovers or in the atmosphere through telescopes and orbiters. Common biomarker molecules include methyl chloride and dimethyl sulfite. In some cases, planets may have elements such as oxygen, methane, or hydrogen as predominant components. Earth's life forms are carbon-based, as carbon is the dominant element on our planet. If a planet lacks carbon, life forms there could have a radically different structure. For example, life forms based on hydrogen would be unrecognizable to us, especially when viewed through the lens of our own biochemistry. Planets like K2S18b are rare because they share the same key biomarker as Earth, carbon. The James Webb Space Telescope, or JWST, has revealed the presence of carbon molecules alongside traces of methane and carbon dioxide on this planet. This discovery positions K2O18b at the forefront of Earth-like planets with the potential to support biolife. Kepler K2188b isn't the only noteworthy planet. Another intriguing but debated candidate is TRAPPIST-1b, discovered in 2016. This planet is about 1.5 times larger than Earth, and data indicates it may be capable of supporting life. According to NASA astrophysicist Thomas Green, TRAPPIST-1b has a thick atmosphere that helps protect its surface from excessive heat or radiation. However, the planet orbits much closer to its star than Earth does to the Sun, receiving far more light. The JWST has found that TRAPPIST-1b's daytime temperatures exceed 200 degrees, making it lethal for humans, yet possibly ideal for other types of life forms. With advanced space telescopes like the James Webb, we can now explore the atmospheres of distant planets in greater detail than ever before. Thanks to the recent incredible discoveries by the JWST, it seems clear that many more astonishing findings are on the horizon. In fact, some scientists believe that there could be planets in the universe with even more favorable conditions for life than Earth. These planets are known as superhabitable worlds. Imagine a planet that is larger, safer, and more hospitable than Earth, free from the challenges we currently face. Though still a theoretical concept, superhabitable worlds would likely be older, bigger, warmer, and perhaps even more humid than Earth. Many researchers speculate that these planets might orbit stars much older than our Sun, with significantly longer lifespans. For example, while our Sun has an expected lifespan of about 10 billion years, it took nearly 4 billion years for life to develop on Earth. Some stars, however, can last much longer than 10 billion years, allowing for a more prolonged and intricate evolutionary process on their orbiting planets. But how can we locate these ideal planets? According to many experts, the best approach is to search for planets orbiting orange stars that are cooler and less bright than our Sun. Such stars would need lifespans between 20 and 70 billion years. It is believed that life on planets around these stars could evolve fully, reaching a point where the planet's geological features and life forms are at their most developed. These superhabitable worlds would likely offer many advantages over Earth, such as more landmass, heat sources that last longer, better protection from radiation, and ideal gravitational conditions. For a planet to be truly superhabitable, it should also have an average surface temperature about 500 degrees Celsius warmer or cooler than Earth's, promoting greater biodiversity. Although no such planet has been found yet, scientists remain optimistic. The scientific community at least has a clearer idea of what they are looking for and where to search. Still, there are skeptics who argue that no planet could be better suited for human life than Earth. If such a planet existed, they claim, it would have already been discovered. However, it's important to note that the technology we have now wasn't available in the past, which might explain why we haven't found one yet. Perhaps with future advancements, our telescopes will one day reveal the perfect planet for humanity. For now, the search for a new home continues. Thanks for watching this episode. Be sure to click the video on your screen for more fascinating insights into space.